like 6 months ago. It has been there for a while. All right, so 11.2. Talk about surface areas. Prisms today. We'll do prisms today, cylinders tomorrow. Identify what a prism is. A prism is a polyhedron. Remember, polyhedron is simply a three-dimensional shape in which all the surfaces are polygons. Okay, so a prism is one of those. But it has two identical ends. The two identical ends we call bases. And all the other faces, all the other polygons that make up the prism are rectangles. Okay? And actually, let me rephrase that. They are parallelograms. That'd be the best way to say it. Okay? Most of the time they're rectangles for us, but we're going to see them occasionally as parallelograms. So a polyhedron, okay, a prism is a polyhedron that has two identical bases, and all the other sides we call lateral faces. And those lateral faces, like I said, are either going to be rectangles or parallelograms. Okay. Right there, that is, and it's based off of so when we look at I think it's a little bit easier here with this shape than it is others. We can identify that the two bases are going to be the identical pairs. They're going to be parallel, okay? And usually, if they're not all rectangles, the bases are going to be the non-rectangular surfaces, okay? So if I look at that shape right there, those are all the what we call the lateral faces are rectangles, okay? The base right here would be a trapezoid. Does that make sense? So we would call this a trapezoidal prism. Trapezoidal prism. One thing that is very difficult, I think, are any of us like really great at art? Okay, so if you're good at art, you might have no problem drawing these. I usually find out the people that are better at art are the people that can better visualize the three-dimensional shapes with perspective and all that kind of stuff. Drawing 3D shapes on two-dimensional surfaces obviously takes a little bit of skill. I want to show you what this shape is here. Put that in. All right, so we have that shape, and I'm going to actually get rid of the axes here so it's not cluttered. That is the shape that is the base. Does that make sense to everybody? Okay. If I take that shape, okay, and actually probably K would be best. Okay, so I've got my shape here that I'm going to make this K value 0. So that's the two-dimensional base. Okay. Now, if I make the height of this grow, give it a third. So right now it's only got 2 dimensions, right? Okay, left, right, up, and down. Okay, and that's usually looking at like something like this. Okay. Now, so that's the only dimensions here right now in this viewpoint are left, right, up, down. If I put the axes in, you only see 2 axes, right? Okay. Now what I'm going to do is I'm going to provide it depth. So I'm going to bring it towards me. Now you don't, because we're looking at a kind of bird's eye view right now. you're not seeing this thing grow towards you. But once I do that, now you can see that it's coming towards you or going away from you. Does that kind of make sense? So that's the third dimension. Now, if I look at this shape from different perspectives, okay, I don't know if I can change the, no, I can't change the axes of reference. But if I'm looking at it straight down, I get that, which is a trapezoid. Looking straight on at it like this, though, what would you consider maybe this blue surface? What would you call that blue surface? That's probably a rectangle. It might be a square, but it's probably a rectangle. So that blue surface, now in that perspective right there, it might not look like a rectangle to you. This angle right here might not look like a 90-degree angle, but that's because of the perspective of a three-dimensional object in a two-dimensional surface, okay, or a plane. So, but now if I look at it like that, would that angle right there definitely look like a 90-degree angle? Yeah, okay. That surface right there, okay, make it orangish. That surface there, is that a rectangle when I look at it straight on like that? Okay, is this one, kind of see this surface GHDC, is that going to be a rectangle? And then this one here, FGCB, okay, or I guess FGCB, that is also a rectangle, right? So all of these, so I'm going to see if I can just color this all the same color real quick. This program, when it's in 3D, it takes a lot of computer RAM, so it'll be laggy when we do this. So I apologize for that, but all right. Rapid access memory. So if I have, so that red shape right there, all red, okay, is a polyhedron. We've got 6 surfaces, okay. This surface here, that is blue now, and that surface there, that is blue, because those are opposite and exactly the same shape. They are congruent shapes. Those blue shapes are congruent. Does that make sense, everybody? That's what classifies those as bases. Okay? People will ask, and because there's a condition about bases that we want them to be parallel. Okay? So if I want them to be parallel, somebody will say that maybe that purple one and that purple one are also bases. They are parallel, but why is that purple one and that purple one, why are they not considered bases? They're not the same shape. Okay, they're both rectangles, but they're not congruent rectangles. Does that make sense, everybody? So that blue one and that blue one are our bases. Okay. Another, and I can't. Maybe I can do this. Let's see here. Trying to get this thing to, there we go, select that, and I want to rotate it maybe around point know. I don't know if this will work. Nope, it won't work. I kind of envision like taking this. Could I put this purple right now? The blue is kind of like on our tabletop, right? Does that make sense? So I put that plane back in. The plane's our table. That would be the bottom of the shape, or we could view it as being the bottom. And a lot of people say, well, the bottom is the base. But could you take this, if you had this in your hands, could you put this purple thing, this purple rectangle on the gray plane? Does that make sense? Would that be the base then? No. The blue are still going to be the base, okay? And that's where we end up having some questions and confusion about what we're doing, because we get into using terminology that is different in the math realm than it is in your everyday interaction, everyday kind of vocabulary realm. Does that make sense? Okay, so you just got to make sure that we understand in mathematics when we say base that there's added characteristics that make something qualify as a base. All right, so here's just some other examples. Okay, that one on the left. Okay, and again, you can look at the one on the left and say, oh, I know that the pentagons are going to be the bases because they are the surfaces that are different than any others, right? There's 7 surfaces up there. 5 of them are rectangles. 2 of them are pentagons. The 2 that are different are going to be my bases. Is that okay with everybody? Okay. Those are my bases. Then all the rectangles would be considered our lateral faces. So it's a pentagonal prism. The one on the right, okay, 5 surfaces. Now 2 of them are triangles. The other 3 are rectangles. So then the triangles are going to be our bases, and we call that a triangular prism. Okay, and that's probably the prism that you guys are most familiar with from like a science class, right? Light refracts inside a prism, breaks it up into the rainbow, right? Did you ever do that in science? Okay, so what's called that device is called a prism. Okay, let's talk about these real quick because it's a very simplistic shape, but it gets people very confused sometimes. So let's see, let me go back to view graphics 2. Let's take this. I want that off. There we go. Okay, so what kind of shape is this blue shape right here now? Rectangle. Okay. Let's make it a little bit thinner. All right, rectangle, right? Over here, what does that produce for us? What would you call that if the base is a rectangle? It's a rectangular prism. Okay, now here's where it gets confusing for people, and it's a unique situation. Okay, would you agree that those blue surfaces are congruent rectangles and they're parallel? So they're bases, right? Okay, but would you be able to argue that that purple one facing you and that purple one now facing you, those are also congruent parallel rectangles? So those could be classified as bases as well. Does that make sense? Okay, so the blue ones could be bases. The purple ones could be bases. What about that one? Is that a rectangle, that red one? Yep. So the red ones, and the way that we would determine if they're bases or not is that one congruent to that one? And they're parallel as well, right? So that means that that red one and that red one could also be considered bases. Does that make sense, everybody? Okay. That changes things for us Because once you identify, and that's what you want to do every single time that you come across a problem, is identify the basis first. Because then once you identify the basis, that is going to dictate what the other components are. Okay, so if I've got this rectangular prism here, okay, would you guys agree that this is a rectangular prism? Okay, most of the time if I set it like this, most people are going to say that's the base, right? And then the top is also base. Okay, if I set it like this, most people are going to say this is the base and that's the base, right? Okay, and we get in that common practice of top and bottom being a base. Okay, because it doesn't matter. This is what you were introduced to maybe in the 7th grade and 8th grade. With a rectangular prism, it doesn't matter what you choose the basis to be. So a lot of times in those courses, they just say it's top and bottom. And that's where we get confused and we run into problems when we want to see maybe a shape that looks like, see if I've got one here. Maybe I see a shape like this one. Okay, the one on the right. And you might think, oh, the bottom, which most people are going to say the bottom shape and the one on the right. Come on, tablet. Really? All right, so the one on the right, they misdefine that as a base because they get used to saying, oh, it's just a surface that the shape is resting on, okay, or the bottom, and that's not the case, okay. So just be leery of that as we move on, okay. Altitudes then, because this is what we're going to try to do is we're going to develop some formulas that allow us to find surface areas and allow us to find volumes. Okay. Now, do you guys remember when you guys did surface areas? You guys ever heard of a net? Okay. And I think I can show you or demonstrate a net for you in GeoGebra. So the net is kind of unfolding the three-dimensional shape, right? Does that make sense? Okay. And you guys probably in those courses, I don't know if so when I hide some stuff, it removes the things that's attached to. Let's just view it that way. Straight on. If I want to find the surface area of this prism in other classes, you would break it down and say, okay, I'm going to find the area of that rectangle. I'll find the area of this rectangle, find the area of that one, find the area of that one, and this blue one, and add them all together, right? Okay, which is fine, that works, but there are some other techniques that are much quicker that we're going to try to develop in this course. Okay, so that's the idea, is that especially when you guys have seen something in a math course, you're like, I did this in 8th grade. I know how to do this. Well, when we do it again, we're doing it for the purpose of diving a little bit deeper, getting a little bit a greater depth of knowledge about the topic. Okay, so an altitude is any segment joining the two planes that contain both bases and is perpendicular to both. We need to be able to identify what an altitude is to be able to come up with these more convenient formulas for finding surface area and volumes. Okay, so the altitude is just what you would think about. If you had that shape in front of you on your desk, and I gave you a tape measure and I asked you to measure it, okay, measure the altitude, you would measure essentially the height of it, right? And that's from the top prism, or sorry, not the top prism, the top of the prism to the bottom. And in this case, that's because that we've got this base, or this base here on the bottom, actually resting on the bottom or on our desk. Okay? If we were to look at this shape right here, okay, this is the exact same shape. Okay? And if I ask you to find the altitude of that shape, it's no longer, if I was sitting on my desk in that orientation, it is no longer how tall off my desk that thing rises. Does that make sense? The altitude is that horizontal distance now. This here would be the altitude because that is the distance that is one, it's connecting the bases and it's perpendicular to both of them. Okay? So that's what we got to get out of our mind that altitude or height is always going to be considered a vertical distance. Okay? You know, if however tall you are, if you lay down, you're the same height laying down. You're now horizontal, but you're still the same height, right? Okay? That's kind of how we've got to think about that. If we can identify the bases first, and then remember that the altitude is the distance between those two shapes, you're going to be fine with this stuff. Okay? But that is the one main topic, main concept that people struggle with is identifying what does H have to be. And H is the letter we use to identify altitude. Okay? Now, like in that picture, like obviously those dotted lines would be altitudes. Okay, but no matter where I shift those dotted lines in those lateral faces, they're still going to be altitudes. So the best place to find your altitudes are on those edges, the black solid vertical lines there. Does that kind of make sense? Now, it's not always the case, but it is the case when we have what we call a right prism. Okay? If I were to tell you that you have a triangular prism, because I left a word out, it's an understood right prism. Okay? So I should say you have a right triangular prism. Does that make sense? Or you have a right rectangular prism, or you have a right hexagonal prism. If we leave that word right out, it's still assumed to be right unless told otherwise. Okay? Does that make sense? So all of them that we see that does not have the word right in front of it are indeed right. Okay? The ones that are not right are called oblique. Okay? And the way I remember this is that you have, does anybody know where your obliques are in your body? Your abs on the side. Okay? So the way I remember this, my obliques are on the side of my body, hidden under a big layer of fat. Okay? But they're there, promise. But they're side. So oblique, does that look like it's leaning to a side? That's how I remember that, what that word oblique means. So you're going to see the word oblique multiple times throughout the rest of your high school. And generally it means slanted or leaning to a side. Okay? We'll talk about oblique asymptotes at some point in Algebra 2 and college algebra. All right? So that's those are the two different things you're going to see. Okay? A right prism. And so what I'm getting at here is in every right prism, your lateral faces are rectangles. Okay? Every right prism, every single lateral face is going to be a rectangle. And in that situation, if you want to find the altitude, it's just one of your edges of your prism, okay, where the lateral faces come together. Okay? If I have an oblique prism, now my lateral faces are all parallelograms. Okay? And the best way to find our altitude, is to drop, in this case, because the bases are on the top and the bottom, is to drop this red dotted line from the top base to the bottom. So you can envision that as being your kind of your tape measure, and you're going to go all the way down to the bottom of the shape. That is going to be considered the altitude, which is not one of the physical edges of the prism, right? Okay, in a right rectangular, or it's just a right prism in general, your altitude follows a physical component of your shape. In an oblique prism, that's not necessarily true. Is that okay? So this would be an oblique pentagonal prism. Some more oblique prisms. Already talked about that. All right. So let's just talk about surface area real quick. All right. So surface area says it's area. It's going to be measured in square units. Okay. There are two things that we talk about when we deal with surface area. We talk about something called lateral area, and that attaches itself to the lateral faces. So lateral area is the sum of all the areas for just the lateral faces. Okay? And what's nice is if in certain shapes your lateral faces might all be the same rectangle or might be all the same parallelogram. So you might be able to use multiplication to alleviate some of your area formulas for lateral area instead of just adding. Okay? Total area, okay, and our textbook jumps back and forth. A lot of textbooks do this. Total area is all the area of all the surfaces, lateral and base, added together. Okay? Our textbook, like I said, sometimes it uses total area, sometimes it calls it surface area. They're the same thing. TA and SA, total area, surface area, they are synonyms for one another. Okay. As we go through some of the problems, we're going to talk about capital B. Okay, capital B is the area of a base. Now that capital B, that formula it's going to change. Your base might be a rectangle, so then B times H is that area formula. It is what's represented by capital B. If your base is a triangle, then capital B is being represented by 1/2 BH. Okay. If capital B is a hexagon, then capital B is 1/2 AP. Okay, so we have to be able to jog our memory back to Chapter 10's area formulas to be able to determine what capital B is. Okay, so lateral area, that's adding up all your lateral surfaces. If I add those together, I find that value. I don't have surface area because I don't have the bases added together. But we know a relationship between the bases is that the bases are identical or congruent shapes. So if I want to find the complete surface area, I have to find one base and double it, and then add that to my lateral area. Okay? So total area refers to total surface area. So in your homework, they're going to ask you, you just got to pay attention. They might say, hey, on this one, just find lateral area. On the next one, find lateral area. On the next one, find lateral area. On the next one, find total area. And a lot of people on that last one they'll just make the mistake of finding lateral area because you've done it 4 times in a row already. So just be careful, you read the directions, all that kind of stuff. All right, so we'll do examples. It says, what is the surface area of the prism at the right? Okay, so we're going to do both these. Let's do the one on the left. Or let's do the rectangular prism first. Okay. First thing you're going to do is you're going to establish what is your base. What do you want your bases to be here? Okay, you want it to be the top and the bottom. So you want it to be that. And the only reason you have choice here is because this is what type of prism? Rectangular. So you're going to say those are your bases. So I'm going to find capital B, which in this case, because the bases are rectangles, capital B is going to be B times H for those rectangles, right? So for these green, bluish-green rectangles, B times H. So how would I find the area of that rectangle right there? 3 by 4. So it's going to give me 12, right? Then I would double it. So 2B would be 24, correct? Now let's find lateral area. Okay. Lateral area is going to be all of these other rectangle. So that rectangle there plus this one here, which what are you going to know about those two that are purple? They're the same. They're both what? Are they 3 by 5, right? So those purple ones are 3 by 5, so it doesn't give me 15 for one, but then I'll double that, right? Plus then, the one in front of you, the one here would be what? The closest one to us would be an area of 20, but then you've got that one in the back, right? So you'll double that as well. So it's going to give you 30 plus 40, which would be 70, correct? Okay, so then if I want to find the total surface area, or surface area, it's going to be lateral area plus 2 bases. Our lateral area was 70, our 2 bases were 24. It gives me 94 square centimeters. Does that make sense? Okay. That's kind of how you probably did it in 8th grade. Would you guys agree with that? Okay. That's essentially, we didn't draw the net, but that's essentially the construction of the net, and then looking at those two-dimensional areas and together. And that's fine. We can do that. Okay. Let's do the next one. Let's do what would you call this one? Triangular prism. And because you called it a triangular prism, you're telling me that that right there and that right there are the what? There are the bases. Okay? So if I want to find B here, B is now defined by 1/2 BH. Capital B is 1/2 B times lowercase h. Now remember, those are just for this triangle here, correct? What kind of triangle is this blue triangle? It's isosceles. Okay? So when we have an isosceles triangle, isn't that right there H? Okay? What does that do to this side of 6 right here? What does that create right there? Makes it 3. Do you may remember what I can do to find that lowercase h right there? Say again? Okay, so you can remember that that it's a 3, 4, 5 Pythagorean triple. That works. And because we knew it's Pythagorean triple, that's what the way we identified it, you can realize that, well, if I didn't remember that, I could use a squared plus b squared equals c squared to find that h, right? So we got 1/2 b. What's b in this? B is 6. You said h was 4. Okay. Now what I like to you can multiply this all out, but what are you going to do with b eventually? Capital B? Times it by 2. So if this is b, then 2b would be put another 2 there, right? What's 2 times 1/2? Just 1, isn't it? So a lot of times, because I know I'm going to double that area, I don't really worry about that 1/2 out in front, but that's the logic. So that's what 2b is. Okay. Now, lateral area. How big would that rectangle right there be? What are the dimensions of that? 5 by 12? Okay, so what's 5 by 12 as an area? 60. Okay. Now, times that by what? Why'd you change your mind? Okay, good. So this one, that one there closest to you is 60. Okay, and the same wall on the same side, but over here, which would be, I'll outline it. It's hard to, this is what I've always struggled with. This is why I like GeoGebra, but it's kind of a pain in the butt sometimes to build these in GeoGebra. But I can't, like, rotate this and show you that rectangle there in the back. Okay, but it's the same as this one here that we just talked about being 60, right? So we got 60 plus 60. And now what is the bottom rectangle going to be? It's 6 by 12, so it's going to be 72, right? So my total area, or my surface area, is going to be 60 plus 60 plus 72 plus 24. What's that work out to be? That's 96 there, right? This would be, what, 120? Is that 160 or 216? And it would be centimeters squared. Okay? That's the default way. That's the safety net way of finding the area, the surface area of a prism. Let's look at this real quick. And I'm actually going to go back to, we'll just stay here. Don't look at this yet. Ignore that. All right. So if I want to find, so let's just find the lateral area of this shape. So what are the bases? Give me a word for the bases here. They're the what shape or color? The orange one, right? Okay, and that's a pentagon. It's an irregular pentagon, but still a pentagon. If I want to find the lateral area, I'd be adding, try to figure a color out here that I don't want. I would be adding this green surface together with maybe this purple one, with then this purple one there in the back, right? Okay, and then this purple one back here, and then with this purple one there. Does everybody agree with that? So let's go through and find those individual areas. Okay, if I look at this green one, what is this width right here? A. And what is that distance right there? H. So you guys agree that A times H is going to give me that green area. Okay, let's look at this next rectangle here, which would be this one. If I want to find its area, you're going to take B times what? B times H. So that's what we're going to get to. So this here would be C, right? Multiply it by H, and that's going to give me the area then of that rectangle. So write CH. Okay. Now if I take this one, multiply it by H, you guys agree it's going to give me that area? So there's DH. And then what's the last one going to be back here in the back? EH. All right, so what am I going to do? What am I going to do to get the lateral area with all those rectangles? You're going to add them. Okay? Now, here's a little bit of algebra. What does each one of these have in it? H. Let's take that H out real quick. And you'd be left with A plus B plus C plus D plus E, wouldn't you? Start here at A, travel to where B starts to intersect, travel down B, travel down C, travel down D, travel back down E, you get back to where you started, right? What is that purple distance called? Perimeter. Okay, so I'm going to take this here, A plus B plus C plus D plus E. That's the perimeter of my base, right? So lateral area, we found lateral area was initially rectangle 1 plus rectangle 2 plus rectangle 3 plus rectangle 4 plus rectangle 5. Now we're seeing we can write it as lateral area is the perimeter of the base times the altitude. And that's probably not a formula that you saw in 7th grade, 8th grade math. Okay? If we come back up here, let's see if we can do this now a little bit quicker. Okay, and I think this one was probably the most elongated problem. And I just want to figure out that right there, because the LA equals PH. It's only going to find me the lateral area, okay? So that we identified the bases. The bases were these triangles, right? What is that what is that perimeter of that triangle? 16, okay? So P is 16. What is H for the prism? H is that distance right there. It's the distance between the two bases. So it's 12. Okay, so what's 16 times 12? What's 16 times 10? 160. Okay, and what's 16 times 2 then? 32. What's 160 plus 32? 192. What's this add to? 192. Was that a little bit quicker? Yeah. Okay. Now I still need to be able to do this here to find capital B. Okay. But a lot of our formulas as we move on, and we'll pick up with this. We're going to stop here. We'll pick up with this again tomorrow. We're going to write, when I find surface area, I'm going to write it surface area is equal to lateral area plus two bases. And then a lot of times I'll say, okay, well, lateral area is always P times H. Plus two bases. Now what's two bases here? What are my bases in this shape? The triangle. So I'll take the B and I'll replace it with 1/2 BH. And now I have a formula, specific formula for that triangular prism. And if I can find P and I can find H, okay, and I can find lowercase b and lowercase. So now here's the issue that people also run into. So when I say P times H, that's the perimeter of the base, that's the altitude of the prism. Does that make sense? Okay. So that H right there is going to be the 6. Does that make sense? Okay. When I come over here, remember capital B was the area of the base, right? So this lowercase b is the base of the triangle in this case, and H is the altitude of yes, which is the triangle, correct? Okay. So H and H again, right? They're the same variable, same letter, but they represent different components in that shape, and that's what people struggle with. So a lot of times it might be a good idea for you to say, okay, this is H of, and maybe you put like a lowercase p there for prism. And then this is H of, and maybe put a lowercase b there for base. Just some type of notation, or sometimes I'll use like a 1 and a 2 as subscripts. Just some type of marker to realize that they are different H values if you're going to do it that way. Does that make sense? Okay. So just be on the lookout for that.